All right, all right, all right. Let's take a quick look at current events. Are we here? Yeah. All right, let's see here. ChatGPT powered sentry gun. What is this? Oh my goodness. Uh-huh. Hmm. This sounds wild. Just kidding. I don't know. I don't know. All right. Back to my homeland. Exorcism. Let's go. Okay. So, the challenge is over. Right? Here's the challenge. This is over, baby. It's over, over, over. That's exciting. Um, just that down. So, this means, why am I coming back here? Well, I'm just going to tell you. So, today is what, the 10th? Today's the 10th. So, tomorrow is going to be the second Saturday of the year. I did, in fact, miss the weekly leak code contest last week. But starting tomorrow, I'm going to try and do it every single week, all right? And I want to do it in C++, but I was looking, and the truth of the matter is, I just don't know much C++. I just don't know much C++, right? We used it in school and everything, but I just don't really know much. So I'm going to come on here, I'm going to come into my language track, all right? And I'm going to, excuse me, I am going to choose C++ from amongst these options, all right? And of course, we did some already during the challenge. All right, so here it is, C++, great. So we've completed 4, I guess. So we completed the hello world, good. And the reverse string, sure. And secret handshake, given a decimal number, okay, yeah. And the all your base, that one's fine. Okay, so now what are these ones with like a light bulb? Wait a minute, wait a minute. Why is it like a light bulb? Learning exercise? Oh, interesting. A learning exercise. Okay, so that's good. So now the other thing is, Vang gave this feedback on a solution very similar to yours. Congratulations, this is an exemplar solution. Okay, sure. Okay, let's not worry about the hello world. Let's go to exercise 2. Okay, so here it is. So let's try and pop right in here. Oh, you know what? Something else I was gonna show. I've been messing on my Mac with, actually there's not much to do with it, honestly, but there is this thing, ASCII Aquarium. Uh-oh, brew might take a long time. It might sit here upgrading things for a while. Let's see. 45 outdated formulae. Okay, I just want to show this. It's all these fish, right? Curses boot C, loadable library and Perl binaries are mismatched. Yeah, I had to mess with my Perl installation to be able to get the exorcism exercise to work. And I guess I did it pretty ineptly because now my ASCII aquarium won't work. Dag nabbit. Alright, I'll leave it alone for now. Should I leave it alone or should I try and troubleshoot this? Let's see. So the curses boot C, loadable library, and Perl binaries are mismatched. Okay. So, yeah. So clearly it shouldn't work if they're mismatched. But what do you think we're supposed to do about it? We're supposed to troubleshoot our Perl installation, I guess. Okay, let's see. Ubuntu troubleshoot Perl installation. Let's just take a look. Okay. So let's do what they suggest. We know it's already installed and everything. Newest version. I guess. Okay, let's see if there's anything. Delete Perl 5 and reinstall the modules you had locally installed. Well, is that a surprise? Maybe a little bit. Perl brew? -2. Okay, let's have a look. What is Perl brew here? Sounds like a winner to me, baby. Honestly, this sounds like a winning item. And look, what the? The ninja's clothes come off when you hover him? That's crazy. Okay, so let's try this. Why does it have a slash in front of curl? I don't know why that would be. Hmm. Okay. So should we do that all the time? Let's see. Perl brew root is initialized. Okay, sure. This sounds fine. And then, so let's try this Perl brew again. Whoops. Uh-oh, this could take a while? Oh, no. Okay, let me just open another one, and let's go to the C++ now, and then I can come back to this. Okay, so I'm going to copy this. And let's see what we get here. All right, so let's go to exorcism, CPP, log levels. All right, so this is the first learning exercise, apparently, and it has hints. Let's look at the README. Okay, so we are gonna do some of this, and maybe it's easy. I kind of hope this one's easy. I could go for something easy to sort of ease myself into this. So, check out hints. In general, you don't want to reinvent the wheel when it comes to programming. For many standard algorithms, there will be someone who might have already done your work for you. Yes, this is something to keep in mind. So, to include the content of other files, C++ uses the include directive. These includes should be stated at the top of the file. During compilation, the line with the directive is replaced by the content of the respective file. Yay! Namespaces are kept as they are in the original file after includes. The standard library offers many common functions, algorithms, and data structures. The standard library uses the standard namespace. Yay! One example is the C numerics library, CMath. It provides many common mathematical operations. Okay, so here we see POW. Yay! Seems like a winner. Standard libraries are included with angled braces instead of double quotes. Okay, cool. The difference is the location where the compiler searches for the respective files. The search in the current project is skipped for the angled braces version, and it directly starts in the system's include directories. If you want to include local files, you would use double quotes. Include, double quote, my file. Okay, so strings. A string in C++ is a mutable object, okay, that represents text as a sequence of characters, letters, digits, punctuation, etc. Okay. Strings are manipulated by calling the strings methods. Okay. So in C++, the string type and the associated functions have to be included from the strings library before usage. You can do so by adding #include string, all right, to the top of your file. They will then populate the standard namespace. The fully qualified name of the string type is standard string, standard : string. Okay. The string literal uses the double quote character. Yay. So great. And then a well-made sentence, I think, is a thing of beauty. Sure. Cool. Common string operations. You can use the plus operator to concatenate strings. Very fun. The School of Rock, Electric Boogaloo. Okay. Original title, and we use plus for concatenate. Great. And then we put a 2 with a string literal. Okay. Plus SQL indicator. All right. Cool. So far, so good, I think. So to use the strings library, you need to know that it is possible to call a function that belongs to an object. These are called member functions. Later in the syllabus, you will learn more about member functions and the connected class concept. All right, so string qualification, awesome. First argument from the index to the end of the string. String who is awesome equals qualification substring 5. And it says me. Okay, so we called a method on there to get a different string, right? The substring. Okay, so second optional argument for the length. Ghost. Haunted books. Okay, so the find function is also very useful. It is called as it is called as a member function on the string and takes a string as the argument. Find returns the 0 index position of the first occurrence in the string. All right, so we said string new release, Apple released a new app. So we went find and it said 0. So it found app here. Okay, fair enough. And then new release find E and it says 4. So we found the E, right? 0, 1, 2, 3, 4. Easy peasy. So in this exercise, you'll be processing lines from a logged report. Each log line is a string formatted as follows. So we're going to put a level and a message. There are 3 different log levels: info, warning, error. You have 3 tasks, each of which will take a log line and ask you to do something with it. 1. Get the message from a log line. We did something like this before on exorcism, didn't we? Was there something about log levels in here somewhere? It would have been a fairly short, easy one, because I don't remember spending much time on something like that. Maybe I'm crazy. What one might I be thinking of? Yeah, you know, I don't think it was here. I did something, I think, a little bit like this, but I don't think it was here. Anyway, that's fine. So, oh, you know what? I wonder if it was prologue. I think it was prologue. Let me see. No, it wasn't. Oh, was it JQ? I think it was JQ. I think it was JQ. Let me see. There, yep. In JQ, we did log line parser. This is fairly similar, I think. So we did trim, message, log level, reformat. That's what we did. Trim, message, log level, reformat. Okay, okay. Good. So not crazy. Get the message from a log line. Implement the log line message method to return a log line's message. Get the log level from a log line. Implement the log line log level method to return a log line's log level, which should be returned in uppercase. Man, I'm going so slow. Actually, I mean, it's still fairly early. Okay. Reformat. Reformats the log line, putting the message first and the log level after it in parentheses. Okay. Sure. So, we know that we see that there's a colon being used as a separator here, right? So if we start by finding the position of that colon, then that's going to be kind of our starting point, right? Sorry. So let's go into our CPP file. I noticed I don't have a header file, but maybe that's fine. So, okay, so it says include string file not found. Why would it be like that? I'm going to go ahead and just say using namespace standard. All right. And then wherever we have this, I'm just going to get rid of it. Okay, so it says unknown type name string, but that's because it thinks the file is not found. So that's coming from clang D, it says, pp file not found. So the clang D, we probably could set it up better, but maybe it'll be fine once we build it. Let's leave it alone for now, I think. So sure, let's see. So it says return the message. So I am gonna make a extra thing here for me. It's gonna be called int. It might be, let's say it's int. And then this is gonna be, should it just be colon? Sure. Colon index, which takes a string line, and then return line dot. All right, so do we remember the method name they gave us? It was find, right? Line find, colon, right? Okay, so what do we think about that? It says unknown type name string, so that's not very helpful for us, but we'll see. So here, when we go to return the message, so if we find that spot where the colon is, then there should be a space after that, right? And then, and then the message starts. So do we add 2? Like if the colon is at 0, and then there's a space at 1, and then we take the substring starting at 2, is that what we want? I think so. So let's add 2. So we're going to say return line substring 2 plus colon index line. Okay. And then for the log level, now we have to, so if the log says info, so info, so the O is at index 3, and then the colon is at index 4, we can use 4 as the length, right? So we'll start at 0, and then we'll use colon index line, right? Okay, so now when we want to do this, we're going to use string concatenation, the other thing they showed us, right? I like this. It's very like logically put together, it seems. So we're going to say return, whoops. So we're just going to do a little bit of a concatenation, right? Should be simple enough. Although it would be nice to use like a printf type formatting also, but let's just use a concatenation. So we're gonna do message line, we're gonna do plus, and then we're gonna put a space, I guess, and a parenthesis, okay, and then we're gonna put another plus, and then we're gonna put log level line, and then another plus, the final one, and then a closed parenthesis, and then that's it. Okay, so let's see what happens when we try test. It might not be ready yet. Let's see. No target specified and no make file found. So I think this is what we did every time, right? cmake -big G Unix make files, sure. And then we did dot for this directory. I think we're okay. And then we did and make and ctest-v. Okay, let's give it a shot. Uh-oh. It doesn't usually take very long to build these. What's happening? Oh, I guess we're fine. No tests were found? What the... So why didn't it find the tests in the log levels test CPP? So what does exorcism test do now? Anything different, or is it the same? Oh, it says passed. Okay, let's look at the tests. It says just one assertion. We want more than one assertion, right? I'm sure. Okay, so most of them must be turned off, I guess. No matching constructor for initialization. So here again, these are not good, these are not really good messages, right? So we probably want to set something up in our editor to be like, oh, hey, like, what is it saying? Catch source line info, including the catch HPP. Yeah, I don't know. And saying unknown type name string, that's silly, right? Really, that's not set up well. Anyway, so should we just get rid of the hash if down here? Sure. Okay, so okay, so it looks like I'm including square brackets that I'm not supposed to include. And yeah, okay, so let's fix that. Oops, not this one. Okay, so yeah, string file not found, that's not a good message. That's not a helpful message. So let's finish this up and then let's see if I can find the way to set up that clang D stuff, because that's not right. Clang D. It's like this LSP, right? It's messed up regardless. So, which one were we fixing here? So we would just want to get rid of those square brackets, right? So this will be changed, and I guess here we actually subtract 1. And then are we good? I think so. Let's see. Oh, let's CMake again. Oh, interesting. Oh, I was supposed to subtract 2, 1 for each bracket. That's a dumb oversight. We were supposed to subtract 2, 1 for each square bracket. Okay. Fair enough, fair enough. Alright, so now it says passed. Okay, so now let's try and submit. Okay, so let's go here. Processing, nice, nice. So this covered the concepts, I guess, of strings and includes, so that's good. And are we done? Are we done processing? Yeah, passed. Okay, so let's go ahead and mark as complete, I guess. Oh, and I think, did I want to write down how many I was doing? Yeah, give me 1 second. Let me find the notebook that I want to be using. Uh, one minute, actually. Hold on, 1 minute. I'll be right back. I feel like my confidence is at a low ebb in many respects. All right. So, I guess I'll just make a note here for myself that I did one. I'm just going to mark it right on here. One. All right. So far, so good. Oh, apparently we unlocked concepts, whatever that means. So that's cool. So, So this really isn't actually my problem, but maybe it's this one? Ah, okay. This looks more like it. Oh, interesting. Okay, let's give it a shot. Yeah, 11, 12, same as there. So they searched for... It said they used this one, dev. Why does this one have a 1 here? LLVM C++ standard library. What is pick here? Shared library subset kit? Okay, let's give this a shot. Oh, they ended up using dev. That's what we need, right? Development files. Okay. So lib, and we want standard C++ 12. So does this make it better? That's what they're saying, right? They said they resolved it here. Problem was solved after they did this. Okay, let's see then. Oh, okay, so those nasty messages do in fact appear to be gone. Thank you, Stack Overflow. Yeah, baby. All right, so that's great. Let's go back and look at the Perl now. So what did this do? So we did Perl brew. Oh, failed. Dagnabbit. Okay, let's take a look. There's a lot of output here, huh? So, where do we think it actually failed? Oh my goodness gracious. Okay, so here's the bottom. It says result fail. Failed test 21. Oh. Okay, so here's failed test 21. Long body lines are wrapped. Maxlen 1894. Jeez. Well, that seems pretty effed up. Should we try a different number? Perl brew init. That sounds wise. Available Perl versions. Wow, it goes up to 5.400. And what did we try before? 536? Okay, well let's try this newest one. So we'll go Perl brew. Whoops. Install Perl-5. Then we'll go 400. Yeah? Okay, so let's see what it says. Is this one also going to take a while? Yeah, this could take a while. All right, cool. So let's go to the next thing on exorcism. Close all these. All right, so we did log levels. That's great. Let's refresh. Okay, so that's complete. Let's go to C++. Okay. Oh, wait a minute. So now that the challenge is over, I do want to review community solutions after each one. Now, the trick to this, and I think it is a shame that we don't vote on the community solutions here the way we do on Code Wars. So I guess I'm just going to go by highest rep user, but that is a poor substitute for actually voting on the solutions the way we do on Code Wars. But whatever, let's see this one. So, so they did not do using namespace std. Actually, using namespace std, yes or no? So somebody says, I have heard, this is 15 years ago, but it's got a lot of upvotes. So I've heard using namespace std is wrong, and that I should use std : cout and std : cin directly instead. All right. Why is this? Does it risk declaring variables that share the same name as something in the std namespace? Are there performance implications? Okay, so I'm not trying to worry about performance implications right now, but it might be interesting, right? So let's take a look. So Greg Hugel says, consider two libraries called foo and bar. So we said using namespace foo, and then we said using namespace bar. So far, so good. Everything works fine, and you can call blah from foo and quooks from bar without problems. But one day you upgrade to a new version of foo 2.0, which now offers a function called quooks. Now you've got a conflict. Both foo 2.0 and bar import quooks into your global namespace. This is going to take some effort to fix, especially if the function parameters happen to match. If you had used foo : foo : I can't even speak. I'm a mess. Foo : blah and bar : quux. Then the oh my gosh. I'm dying. Okay, so let me start again. If you had used foo : blah and bar : quux, then the introduction of foo : quux would have been a non-event. Okay, so So, do we need to read these comments or anything? Oh, it can get worse than what Greg wrote. Um, so I am not going to worry about it. I just want to use standard STD for now. Should we see what else? I mean, like, I'm sure this is fine. Oh, wait. Standard string view. Is this from algorithm? So return standard string, line.substring, line.find, square bracket, colon, space, +3. Okay. Let's see here. So why was string view passed in? Let's take a look. Let's take a look here, baby. Basic string view. Okay, so standard string view. Why is it basic, standard basic string view? Oh, here we go. No, it keeps going to the same place. Huh. Okay, I guess it's fine. So, describes an object that can refer to a constant contiguous sequence of char t with the first element of the sequence at position 0. I'm tired. I wish I weren't tired. this is a good one, huh? Yeah, baby. It is the programmer's responsibility to ensure that standard string view does not outlive the pointed to character array. Okay, so let me put a star on this. This is good information. So we used standard operator, double quotes with S at the end, destroyed at the end of the statement. Okay. All right, what else do we want to find here? It's a pretty basic one, right? So they use substring and find. That's cool. So here they found the square bracket and subtracted 1. Is that better than my finding the colon? Probably, maybe. And then let's see. Oh, we used auto here and here, so we said message. So I didn't end up doing that. I just sort of put everything into one line. And I think that's probably okay for me. Oh, here's something we could do. Okay, cool. Yeah, I'm good with that. Let's go to the next. I spent a lot of time already, so maybe a little less time on this next one. So this one is called lasagna. I feel like I should be going faster, probably. Just sleepy, sleepy, sleepy. All right, let's go to lasagna. Oh, wait a minute, wait a minute. One more thing before I leave here. Let's see what the hint said. So here's a tutorial. Oh, okay. Oh, never mind. It's dead. All right. Basic string class has many useful built-in methods. Let's take a look at this one. Oh, it broke it. Get the log level. Simplest way is using plus. Oh yeah, printf. I said I'd like to do it with printf, right? So you know what? Since that is mentioned, sorry. Since that is mentioned, let me go ahead and try doing it with printf. Oh, bad request. C standard IO printf. Is this C standard IO still? Yeah. Okay, let's try it. Let's try it. So I'm gonna come up here and I'm gonna say hash include C standard excuse me, C standard IO, right? Okay, not used directly, but we're getting there. So then instead of doing this, let's return sprintf, and then we're going to put S like this, and it's going to be message line, and then it's going to be log level, right? Let's see if that works. No viable conversion. Okay, so sprintf is int. Okay, let's take a quick look. So sprintf is what I thought it was, but that gives back an int. Oh, wait, okay, hold on. So we need to, okay, we need a buffer to return it from. That makes sense, but off the top of my head, I can't think exactly how I want to do that. So sprintf, we need to pass a buffer in first. So we're going to say char star buffer equals, and then it's going to be the length of the string. And we're getting rid of the colon, so I guess, well, you know what? I think it's fine this way to start with, maybe. Oh no, we can't do that. Hold on. Hold on, let's see what they say about using the buffer. Let's see, yeah, the example. So sprintf. I'm not used to doing it this way, and I feel I'm really dumb right now. Okay. So this is undefined. Sprintf buff %s text and then buff. Okay, let's see. Pointer to a character string to write to. So buff size is used if we do sn printf. So let's see. Return value is number of characters written if successful, or a negative value if an error occurred. Okay. Variable argument list. These sound interesting. Let's blist is variable argument list containing the data to print. Okay, okay. Man, my energy is so low this whole year. Okay, come on. Okay, so buffer, pointer to a character string to write to. Okay, let's take a quick look. C++ array. I did, how many times did I do this in the last couple months? Maybe not that many, but still, like, come on, man. All right. Forbids variable length array. Okay, it was just saying, I thought it might, but it was just saying variable length array here, right? This is C. Well, there's my problem. Oops. Okay, now let's look at the sprintf. I I hope I'm learning something. I better be. Oh my goodness. So can we cast to char array? I'm not very well set up. Here, let me try and improve my posture for a second. Okay, let me see here. All right. Okay, so this is string class. Oh, wait. All right, so where are the methods? We're going to try and get used to this. Convert a character array literal to basic string. Okay. Oh. Should I do this? Okay, let's take a look. Hey, it worked. Okay. How long did I spend? Oh, not terribly long, but yeah, okay, cool. So, great. Let me see here. Let me see here. Let me see. Okay, so this is what I've got. So I tried to make a buffer and then use sprintf. Well, I definitely liked using the plus better. Oh my goodness. Okay, what else is in the hints? All right, I think I'm okay with it. So we'll submit that as a second iteration, I guess. But the original iteration was better, quite frankly. Okay, let's for real move on now to the next exercise. Lasagna. Okay, what is lasagna about? Let's take a look. I'm taking so long. This is gonna take me forever if I go at this rate. It's so slow. Okay. Variables, function calls, and comments. All right, so comments come in two flavors, single and multi-line. Everything that comes after double slash on the same line is ignored by the compiler. Multi-line comments are also known as C-style comments. They are surrounded by slash star and star slash. Anything that comes between these will be ignored as well. C++ is a typed language. All types need to be known at compile time, and you generally need to state them explicitly. A variable's type cannot change. An integer variable with the name years can be declared like this, int years. It is good practice to initialize variables upon declaration. C++ offers different mechanisms to do so. The version with the curly braces is more in line with modern C++, but the equal sign version is also very common. Okay, so I've always used the equal sign version, but let me try. It says this is what? More in line with modern C++, so let me try and just get into the habit of doing it this way. Right? Did I use equals signs in these solutions? Let's see. So I did not. No, I didn't. So I did not use equal signs, but if I'm going to declare a variable, let's try and remember to do it using this syntax. The version with the curly braces. C++ does allow using uninitialized variables. Until the variable is deliberately set, it is undefined and might contain anything. To avoid used before set errors and undefined behavior, it is advisable to always initialize. Makes sense to me, baby. Undefined behavior can crash your program at the worst possible moment, while it was running fine previously. It cannot be stressed enough. Avoid undefined behavior at all costs. All right, fair enough. Arithmetic operations. So we have the star, the plus, the minus. an expression like 3 times 2 or tomatoes plus potatoes? Sure. Updating variables. You can reassign variables as long as they keep their type. All right, so we said tomatoes was 80 before. So now we're going to say tomatoes equals tomatoes minus 5. Sure. Now 75. And then we said potatoes equals 32 times 2 plus 11. Potatoes is now 75. Functions. Functions have a name, a return type, and a possibly empty parameter list. An example of a function named always47 that would always return 47 would look like this. So we put the data type int, the type name int, always47, sure, return 47. Very fun. Here is VIP fee, which has one parameter. Okay, so this one, VIP fee, so we have to pass in an int standard fee, fine. VIP fee calculates the VIP fee based on the standard fee. So we say int VIP multi, and we say it's going to be initialized as 3. And then we return standard fee times VIP multi. I kind of wish it said multiplier instead of just multi. Do we really need to shorten multiplier to multi? It's just weird to me because multi... What is multi usually short for? Multiple, not multiplier. Anyway. Or total fee, a function with 3 parameters and a call to another function. Okay, so total fee, int VIPs, int adults, int kids. And we have an explanation here. Total fee calculates the total price for a group of VIP and adult guests with kids. Kids get a flat discount on the standard fee. VIP guest fees are calculated by calling VIP fee. So standard fee is initialized to 30 and kids discount initialized to 15, sure. So we say kids total fee, so we take these kids and multiply by standard fee minus kids discount, sure, I guess. VIPs total fee, we take the VIPs, multiply by calling a VIP fee, which we defined this previously, so that's cool. And we pass that the standard fee, sure. And adult total fee, adults times standard fee 30. And then we return adding them all together. Functions in C++ do not return the value of the last statement like in some other languages. The return keyword is required for the code to compile. Fair enough, fair enough. To be clear, I mean, certainly I saw quite a few other languages where the last statement value was returned when I was doing 48 and 24. I mean, Elixir, of course. Elixir is the one I usually think of because I think Elixir is the language that first introduced me to that idea. But there are quite a few that are like that. But the languages that I myself have used the most all require the return keyword like C++ does. And I'm talking about Python and JavaScript and Java and C#, basically. So anyway, white space is used for formatting source code and includes spaces, tabs, or new lines. As the compiler ignores unnecessary white space, you can use it to structure your code. Smart use of white space can improve the readability of your code. There are different formatting standards, but these are all conventional and not enforced by the compiler. All right, so here we said int egg yolks equals 3 and int yeast equals 5. And of course we noticed that we were just talking about white space and we added several extra spaces before the word yeast, presumably so that these equals signs would line up. But of course, we could also do it with the curly brace syntax. But either way, so here, compact but difficult to read. So instead, so we liked it this way, like we aligned something, you know, that's cool. And here we just jammed it all onto one line. And I mean, it's just not, it's not a usual formatting standard to just sort of jam these onto one line like that. In this case, like, I mean, is it really difficult to read flour 500, sugar 200? Not really. Now, if you're skimming the page, then you might miss the fact that two variables are declared on. So maybe that is difficult to read. All right, so Lucian's girlfriend is on her way home, and he hasn't cooked their anniversary dinner. In this exercise, you're going to write some code to help Lucian cook an exquisite lasagna from his favorite cookbook. You have 4 tasks, all related to the time spent cooking the lasagna. So 1, define the expected oven time in minutes. Okay, so define the oven time function that does not take any arguments and returns how many minutes the lasagna should be in the oven. According to the cookbook, the expected oven time is 40 minutes. Okay, so oven time 40. Easy peasy. 2, calculate the remaining oven time in minutes. Define the remaining oven time int actual minutes in oven function that takes the actual minutes the lasagna has been in the oven as an argument and returns how many minutes the lasagna still has to remain in the oven based on the expected oven time in minutes from the previous task. So remaining oven time, we put in a 30, right? So that's how long it's been in there, right? I guess. And so then we take the oven time minus whatever was passed in, and we get 10. Yeah? Okay, cool. Calculate the preparation time in minutes. Define the preparation time int number of layers function. Is this stuff too easy? It really is, isn't it? Let's just try and not spend forever on it. Takes the number of layers you added to the lasagna as an argument and returns how many minutes you spent preparing the lasagna, assuming each layer takes you 2 minutes to prepare. So we put in a 2, and we multiplied by the 2 minutes that was given here, and so we said 4 minutes. Fair enough. Calculate the elapsed time in minutes. So define the elapsed time, where we pass in a number of layers and actual minutes in oven. And it takes 2 arguments. The first argument is the number of layers you added to the lasagna, and the second argument is the number of minutes the lasagna has been in the oven. The function should return how many minutes you've worked on cooking the lasagna, which is the sum of the preparation time in minutes and the time in minutes the lasagna has spent in the oven at the moment. Okay, so let's knock this out real quick. Hopefully. Hopefully. Okay, so let's look at our lasagna file. To do, return the correct time. So one thing I wanted to look at is C++ define constant, right? So we can use like a hash define or something, right? Let's look at on Stack Overflow. Macros are used in C because in C, a const qualified variable is not actually a constant, it is just a variable that cannot be modified. Okay. So, let's just say 40. Okay, so we can remove the to do. I removed all the to-dos at once because I'm doing them all at once, I guess. All right. All right, so are we able to do the tests? Let's see. Ah, it's taking a long time to build again. I don't remember it taking a long time like this before. Yeah. Why am I speaking so badly? It's just slurring on my speech. Okay, so interesting. I wonder why it did seem like it was taking a long time here. Not too sure. Not too sure. But regardless, it looks like we're good and done on this one. So let's take a quick look at the hint. Don't forget the semicolon. Oh, wait, did we define anything in this one? We did not, did we? I just returned a literal here. Returned that. Okay. I'm fine with that. Any other hints we should look at? The baking time. You can access the number of layers by using the respective parameter. Okay, yeah, this is really basic. Let's go ahead and submit. Okay, let's take a look. Okay, so I'm going to mark as complete. And now let's go ahead and look at community solutions. And let's again go by highest rep user. We looked at one of his last time. Should we look at one of this guy's? Sure, let's give it a look. So, yep, return 40, yep, this is exactly what I did. So, I'm just going to move on. Let's go to number 3. Oh, let me mark it on the paper. So I've done 2. Let me get my music playing again. Okay, let's go to number 3. I don't know. Honestly, at this point, I don't know that this is helping me at all. I think this is too basic. But let's go to number 3. It's fine. Okay. Let's learn something, huh? Okay, this is another good long one with some details about various things. All right, so the built-in number types in C++ can be divided into integers and floating points. Integers are whole numbers, like 0, 691, or -2. Good. Floating point numbers are numbers with a decimal point, like 6.0221407.6. So don't you multiply this by 10 to the 23rd to get Avogadro's number? Ten to the 23rd, yeah. Okay, cool. I remembered something from school. Not something very useful, but something. All right, 0.1 or minus 1.616. And this is minus phi, right? Not exact. This one is much more precise, but phi 1.616 is, I'm just going to crack that open in here. So the thing about that is 1.616 1 over plus 1, it should be itself. And so we've got to make it a little higher, I think. So I guess you would go and go abs. And you want to minimize this value, right? So that's low. If we do 7, that's lower. If we do 8, okay, so it was 1.618. So that one I did not remember correctly at all. And then if we put a 5 there, okay, so that's not as close. A 1, no, O. It's something around there, right? Anyway, so I misremembered that one. It would have been. So is this something? Oops. So what is this representing then? I don't know. Anyway, that was a weird tangent. M Morales 9241, A Apaic 0x24CD, M Gargan. These are all Marvel Comics characters, right? This is the Scarlet Spider. This is Spider-Man. I think this is Ultimate Universe Spider-Man. Well, Ultimate Universe Spider-Man was at first Peter Parker, but then I think they killed off Peter Parker or something. I don't know. And then this one is this one of the Venoms or one of the Carnages? No, I don't know. But I don't know what this one is. Should we look it up? The Decapitator? Seems crazy, huh? So anyway, yeah, they're Marvel Comics characters. That's fine. So then this one is 0B, and we put a binary number in here. And then B Riley, apparently it's base 8 if we lead with a leading 0. Okay, fair enough. Alright, so when you assign a value to an int variable, you can do so directly with a literal. Alright, so we're using these literals, very fun. A literal is a hard-coded number like 9241. There are different integer literals for several bases of the representation. Decimal integer literals are the most common and use the digits 0 to 9. By adding a special prefix like 0x, it is possible to use other bases. The example above shows the number 9421 in its 4 representations and prefixes. All variables are initialized to the same value. For more details on the different representation systems, take a look at a small tutorial. Okay, so that is here. That's cool. You can use an apostrophe to separate digits for easier readability. 9 apostrophe 241 is the same as 0B 0100 apostrophe 100 apostrophe 0001 apostrophe 100. Okay. or 92'4'1. Okay. Floating point numbers. The floating point literals come in two flavors. In addition to the intuitive 0.0024, it is also possible to use its scientific notation 2.4e-3. The most common floating point type is double. Arithmetic. C++ supports plus minus, times, divide, and then parentheses, and percent for the remainder, right? The division remainder to form expressions. The result from the operation between two integers is also an integer. 5 divide 2 will return 2. Okay. When one of the involved types is a floating point type, the result will also be of a floating point. 5.0 divide 2 and 5 divide 2.0 will return 2.5. And mod is the remainder operator and will return the remainder of an integer division. 5 mod 3 is 2. Assignment operator. The assignment operator assigns a variable with a literal. Always takes place from right to left and never the other way around. Int length equals 5, int width equals 2, length equals width. Here, integer value 5 is assigned to the variable length. Then integer value 2 is assigned to the variable width. Finally, value of width is copied to the variable length, and the earlier value 5 will be lost. Consider also that we are only assigning the value of width to length at the moment of the assignment operation. Therefore, if the value of width changes at a later moment, it will not affect the value taken by length. Assignment operator can be combined with the other operators, arithmetic and bitwise, known as compound assignment operators, plus equals, minus equals, times equals, divide equals, and mod equals. Ooh, very nice. These operators modify the current value of a variable by performing an operation on it. We start with 0 people. So here, they didn't even include the 0 there, right? So we just started with a default value. We need 0 eggs, okay. 2 people joined, people plus equals 2, people is now 2. Let's add 3 eggs per person. Eggs plus equals 3 times people. Eggs is now 6. Okay, cool. Variables people and eggs are initialized to 0. Then we add integer value 2 over the existing value 0 of the variable people and assign it back to people. People becomes 2 now. Later, we add 3 eggs for each person, which turns out to be 6 eggs in total. Now add this 6 to existing value 0 of the variable eggs and assign it back to eggs. Eggs will be 6 now. The equivalent expression would be people equals people plus 2 and eggs equals eggs plus, parentheses, 3 times people. Ooh, cool, cool. I'm pretty much falling asleep. Okay, instructions. In this exercise, you'll be writing code to help a freelancer communicate with a project manager. Your task is to provide a few utilities to quickly calculate daily and monthly rates, optionally with a given discount. We first establish a few rules between the freelancer and the project manager. The daily rate is 8 times the hourly rate. A month has 22 billable days. Sometimes the freelancer is offering to apply a discount on their daily rate, for example, for their most loyal customers or not-for-profit customers. Discounts are modeled as fractional numbers representing percentages. For example, 25.0 represents 25%. Yay. Okay, so it's going to be 1, 2, 3, and 4. 1. Calculate the daily rate given an hourly rate. Implement a function called daily rate to calculate the daily rate given an hourly rate as a parameter. Oh gosh. Should we skip ahead? I'm not ready to skip ahead yet. So we multiply by 8. Great. The returned daily rate should be of type double. Ooh, nice. I'm guessing that the stub file is already going to have this defined as double, so... Alright, so for this one, calculate a discounted price. Implement a function apply discount to calculate the price after a discount. It should accept 2 parameters, the original price and the discount rate in percent. apply discount. Okay, so the return value should always be of type double, not rounded in any way. Okay, so here we passed in 2 ints, right? Which previously they had said that the rate was going to be in a fractional number, but here it looks like an int. But either way, we're going to have to do that. So, implement a monthly rate function to calculate the discounted monthly rate. It should have 2 parameters, an hourly rate and the discount in percent. Okay, so we're going to take this hourly rate, right? We're going to multiply it by the 8, and then we're going to multiply it by the 22 that was previously mentioned, I guess. Right? I mean, that was pretty much defined as a rule. So that's fine. Yeah, so that's cool. That should work fine. The returned monthly rate should be rounded up. Take the ceiling to the nearest integer. Interesting, interesting. Rounded up to the nearest integer. Yes, okay. So, calculate the number of complete workdays given a budget, hourly rate, and discount. All right. So implement a function days in budget that takes a budget, an hourly rate, and a discount, and calculates how many complete days of work that covers. Okay, cool. So we had a budget of 20,000, and we had an hourly rate of 80, with the discount of 11%, and we figured out that that was 35 days. Can I, let's see, can we work that out? Honestly, I don't think, I can't mentally work it out right. We could put it into our console here. All right, let's open that console again. So it was 11% times 80. Let's say it's 1 minus, so that we get the actual rate. And then we're going to do a division. It was 20,000. We're going to divide by that, right? That doesn't seem right. Okay, because this 80 itself needs to be multiplied by 8. Okay, so there's the 35. So we want to go math floor. So that's basically it. Are we gonna screw that up if we do any weird edge cases? Perhaps. Also, it should be noted that this was passed in as an 11.0. So we actually want to divide that. Anyway, so yeah, that's basically the idea there. So let's go into our file. And we've got some to-dos listed. Okay, so the hourly rate, it says 0, but I mean, that's clearly no good because we have to take 8.0 multiply hourly rate. Okay. This one is apply discount. So of course, oh, they're both passed in as doubles. In the README, it looks like they were passed in as ints, I think, but whatever. So we're gonna say, let's see. Okay, so we're just gonna do what we did there, right? Why, I don't know why I brain farted so weirdly there. One, no, that's not really it. So we're gonna take before discount, subtract discount times 0.01 times before discount. Yeah? I guess so. Hourly rate. Okay, so monthly rate. Okay, so then this one is supposed to be rounded up. So we want to use ceiling, and I think that this one is like C math. And then here, I believe we do seal. Okay, we'll see if that's right. All right, last one. And then this is the one that we did in the console before, right? Except this time we already have some of it figured out, right? So we are going to take floor, and we are going to put in all right, well, I don't see any complaints in my editor. Let's readjust. Oh, interesting. So I don't really want that information. Okay, daily rate calculates. Yeah, that's pretty redundant. And yeah, okay. Pretty redundant there. Calculate the monthly rate. Sure. Is it gonna take a long time to build it again? Yeah, I think so. Maybe it was always taking this long and I just forgot. That wasn't so bad, was it? I don't like it. I wish it would finish faster. I don't know. So Um, all right, let's see what it says. So on this one, we might see something interesting on one of the community solutions. Let's find out. So let's again go by highest rep user. Okay, let's look at Bobahop. Okay, so he said const double work hours per day equals 8.0. Const double work days per month 22.0. I don't love the way he used these abbreviations necessarily, but I do absolutely I do absolutely love the way he used this const. So I'm gonna try and keep that in mind for myself. I also wonder whether these could be initialized using the curly brace syntax. Okay, so this multiplication, excuse me, sure makes sense. So the arithmetic looks a bit different here. 100 minus discount divide 100. Let's see how different again that is from 9. I said times 1.0, excuse me. I keep slurring all my words. Okay, this I said times 0.01. I like my way better, honestly. Okay, so then for this one, we said standard ceiling. Yep, pretty much the same there. Although, again, I do love that he used this const. That's smart. And then pretty much exactly the same. Okay, cool. Let's move on to the next then. I'm going to mark that I finished number 3 for the night. I might be starting to speed up just slightly. Man, I am so sleepy. I'm going to keep going for like 2 more hours or more. But I'm going to be sleepy the whole time. Oh, I didn't, Clang format. All right, let's go to the next one. This one is going to be called Last Will. Let's check it out. Okay, so we've got a good amount of detail here. An important method for code organization are namespaces. Ooh, I'd like to edit that. Except what do we want to say? An important method for code organization are namespaces. I would say an important technique for code organization is using namespaces. Two functions might have a naming collision, which can be resolved by putting them in different namespaces. Namespaces can be nested, which might help to structure big code bases. Access to the namespaces is done via the scope resolution operator : The example below shows the use of two different foo functions. They are used together by prefixing their respective namespaces. Okay, so namespace myNS int foo return 44. Namespace my inner ns int baz, return 90. Namespace my other ns int foo, return -2. Okay. So then we show that we can call these, so int my result, and we call my ns double colon foo plus my other ns double colon foo. All right, so there are two different foos. And my ns, my inner ns. Okay. You work for a prestigious law firm that is specialized in handling unique testament requests. In this exercise, you are going to open a mysterious vault. You are the executor of the estate and will assemble the long-kept secret codes of 3 families to get an account number and the matching code. To prevent any family from opening the vault alone, it can only be opened by combining the knowledge by combining their knowledge with a secret modifier that you know from the last will. You have 3 tasks, all related to helping the families to open the vault. 1. Take your seat in front of the families and lay out your papers. Okay. Define a namespace called Estate Executor. The code from the next tasks should be defined in the body of the Estate Executor namespace. Okay, so namespace, some name. And yeah, the space between the curly brackets is called body of the namespace. Okay, cool. Find the secret account number. This is your big moment. Only you have the secret modifier key to reveal the secret account number. Define the assemble account number int secret modifier function that takes the secret modifier as an argument and returns the assembled account number as an int. To get the correct number, you have to sum up the bank number part from each of the 3 families. Okay. Last step, enter the secret code. The instructions in the testament ask you to add all the blue and then all the red fragments. The resulting code is obtained by multiplying both sums. Define the assemble code function that returns the resulting code by combining the fragments from the 3 families to a single integer. The function does not have any arguments and relies solely on the information in the relevant namespaces from the families. Okay. So this is fine. Let's go ahead and look at our file here. Okay, so we have enter your code below the lines of the family's information. So we need to know that it's Zhang Khan and Garcia, I guess. Okay, enter your code below. Namespace, and it was bank executor, I think. And then we're going to have a I got to get the names of these right. Okay. Assemble code and assemble account number. It should be estate executor. Okay, so assemble account number is this one. Okay, so now what did it say to do here? Add all the blue and then all the red and multiply both sums. Okay. I'm gonna try not to fall asleep. Okay, so I'm gonna submit this one and then I'm gonna take like a 5-minute break, basically. Uh-oh, failed. Oh, let's look at the tests. I got ahead of myself there. Where's the last will test? Yeah, got way ahead of myself. Oh, so we did it wrong. Oh, and I know exactly what I did wrong already. I got into too much of a hurry or something. But it is a very simple fix. Wheel, that's a bit embarrassing, I guess. Oh, and it even opened up over here because I just looked at the music. Okay, so let's see. I like this track a lot. Let's take a quick look. This is Golden Gardens from the Chill Hop YouTube channel. Love it. And if we put in Bang Song in the chat, then we'll show it. It just says Golden Gardens, but this link presumably takes us to... Okay, so that's much louder, but yeah, that's it. Arbor Topic. I like that track. So, anywho... oh, did they both fail? Oh, shoot. It said 17 passed. Oh, they both failed. Whoops. It says an error occurred. A state executor has not been declared. Okay, let's take a look. namespace, estate executor. Okay. So I think that is as it should be. Enter your code. Hold on, hold on. Playback paused because your account is being used in another location. I wonder if that's because I clicked the link to open the thing in to open the song in YouTube. All right. I don't know. So anyway, let's see here. So it says estate executor has not been declared. So that's pretty messed up. Is that what it said the first time as well? No, the first time it didn't say that. So what the heck is going on then? Oh, I submitted a test file. Oh, that's silly. Yeah. That's what I get for not paying closer attention. Right? I'm thinking I'm pretty messed up with it. Well, it says passed. I'm going to mark as complete. I'm going to real quick look at community solutions. I don't expect to see much that would be too surprising on this one. Let's take a look at Eric Shearboom's solution. So, I mean, this was already filled in, so let's just go to the bottom part. Okay, so, yeah, I mean, what can you do? So this one says auto red code. Oh, I wonder here as well if you can use the curly brace syntax. Let me take a look at mine real quick. All right, I think it's fine. So I am going to, oh, let me actually check on the Perl again real quick. So, oh, this one said successfully. So if Perl 5.4, let's look at the TLDR again. So let's look at Perl brew list. And so we have that one now. So let's set that as default. Perl brew switch. No. Perl 5400. Okay, now let's try this. It still says the same thing. Well, that seems like it should be right, but that curses boot. Oh, interesting. N snake. I think that one will actually play itself. This is an interesting list. I like the look of this list. But regardless, wait, here's something. libcdk Perl. You think we need something like that? Let's see. Perl interface. It says curses boot C. Let's just try. So sudo apt get install lib curses perl. Let's see what it says. Interesting. Well, I don't think that's gonna help, but let's, yeah. Curses boot dot. I hate it. You know, so that's not there. It's in brew. Maybe it's not gonna work. Well, you know what? Let me try one of these, because some of these sound pretty interesting. Like text-based calendar application or whatever. What's this? Instant messaging client. Oh, Toot. Yep. Mastodon CLI client. N-curses-based radio application. I don't know about that. Let me just take a look at N-snake. Okay, let's give it a shot. Okay, classic snake game. So is this one that'll play itself? Some of them will play themselves as a screensaver type thing, right? It doesn't look like that's the case in this case, but let's just give it a shot. Okay, so here it is. Oh, okay, okay, not too shabby. Let's hit arcade mode. I'm going really slow. Okay, I'm probably not going to play this for very long. Speed 1. Can I speed it up? Am I going to speed up when I eat something? Uh-oh, I'm still going super, super slow. I think my speed should increase, I guess, at some point. I don't know. But this is far too slow. Yeah, that's wild. Oh, wait. Okay, so it quit out completely. Let's see. Options. Oh. Game settings. Let's go starting speed 10. I bet 10 is fastish, right? Oh, 10 is the fastest, apparently. Okay, let's give it a shot. Oh, yeah, that's much better. Okay, so... I'm gonna struggle to play this. It's still too slow horizontally in my opinion, but it's much too fast vertically. Oh, apparently I get 10 each time with the speed being 10. I guess. I died. Okay, well, it looks nice for the most part. I wonder if C matrix will have the same problem. I don't think it's, I think it's written in C, right? Not Perl? I don't know. Yeah, that's fine. Um, anyway, I am gonna put on my regular BRB screen for now, but this makes me think I should make a BRB screen for my actual ASCII terminal. I haven't done that yet, and I haven't even thought of doing that until just now, but that would be a good idea. All right, I'm gonna take 5 minutes and come right back. I need it. I'm falling asleep. All right. Here we go. Next one. Okay, so I marked 3, but how many have I actually done? Was this the 4th or was this the 3rd? This was the 4th. So let me mark 4. Okay. Next. Okay. Oh, this is about Boolean logic. I guess that's fine. Booleans in C++ are represented by the bool type. A bool is either true or false. C++ supports 3 Boolean operators: a bang for not, a double ampersand for and a double pipe for or. You can also use the alternative versions, not, and or. Oh, I like that. I don't think I ever knew that those were available keywords in C++. So, true or false gives us true. True and false gives us false. Not true gives us false, and not false gives us true. Precedence. Okay, so the 3 Boolean operators each have different operator precedence. As a consequence, they are evaluated in this order: not first and second and finally or. If you want to force a different ordering, you can enclose a Boolean expression in parentheses, as the parentheses have even higher operator precedence. Okay, cool. If you use true or false in a place where a number is expected, they will be converted to 1 and 0 respectively. If you use a number in a Boolean operation, everything except 0 is treated as true, even negative values. So if we go not true and 0.0, then we will get false. Well, that's not very helpful because it was false in the first place, right? All right, well, either way. Then we did true plus false, and we got 2 because they became numbers. Fun. In this exercise, you need to translate some rules from the classic game Pac-Man into C++ functions. You have 4 rules to translate, all related to the game states. Don't worry about how the arguments are derived, just focus on combining the arguments to return the intended result. Okay. Define if Pac-Man eats a ghost. Define the can-eat-ghost function that takes 2 arguments: if Pac-Man has a power pellet active, and if Pac-Man is touching a ghost, and returns a Boolean value if Pac-Man is able to eat the ghost. The function should return true only if Pac-Man has a power pellet active and is touching a ghost. Okay, cool. Define if Pac-Man scores. So, define the scored function that takes 2 arguments: if Pac-Man is touching a power pellet, and if Pac-Man is touching a dot, and returns a Boolean value if Pac-Man scored. The function should return true if Pac-Man is touching a power pellet or a dot. All right? Define if Pac-Man loses. Define the lost function that takes two arguments. If Pac-Man has a power pellet active, and if Pac-Man is touching a ghost, and returns a Boolean value if Pac-Man loses. The function should return true if Pac-Man is touching a ghost and does not have a power pellet active. Define if Pac-Man wins. Define the one function that takes three arguments. If Pac-Man has eaten all of the dots, if Pac-Man has a power pellet active, and if Pac-Man is touching a ghost, and returns a Boolean value if Pac-Man wins. The function should return true if Pac-Man has eaten all of the dots and has not lost based on the arguments defined in part 3. Okay. Let's go into there. All right, so can eat ghost. So it says false, but it's not necessarily false, right? Instead, it should say power pellet active and touching ghost, right? Okay. Then this one should be touching power pellet or touching dot, okay? Then this one should be, let's see, so this is lost, touching ghost, and not power pellet active. All right, and finally, not lost, and okay, so that's it, right? So let's get rid of the to-do lines. And let's run test. And then let's turn on the other tests in here. Okay. So that's processing. Not bad, I think. Not bad. Oh, processing still a little slow this time. That's fine. It happens. Okay. So let's take a quick look at community solutions. This one was so simple. Let's look at noon. Oh, Eric didn't have one for this one. All right, let's look at noon. Or is it no one? I don't know. Either way, let's take a quick look. Yep, that's fine. Uh-oh. What is this? If defined GNU-C, pragma diagnostic ignored W unused function. Well, I'm happy that I didn't need that. Although I didn't use the Clang format on mine. But wait a minute, wait a minute. Why is it here and not at the top or something? Oh, you know what? I'm glad that we put auto here. But why do we have arrow bool here? That seems more verbose, actually. Let's look it up. C++ function defined with auto type. C++ does not work this way. The compiler must know the discrete type that the function actually returns. Auto is not a real type. It is a placeholder for a type to be figured out later. This is a fundamental aspect to C++. There are no workarounds. That makes sense, but I was wondering about what this guy did using the arrow bool. That's interesting and a little surprising to me, honestly. So this is not it. But do we have something here? Can we see this? Do we have something here that is related? One definition rule. Deprecated. Namespace scope declaration. So we have struct s static const expression int x equals 42. Implicitly inline defines sx. Const expression int s x declares s double colon x, not a redefinition. I still don't get this arrow thing. Okay, let's take a look. Yeah, this looks more like it. Where could I find out what the arrow operator means in the function heading? Okay, so we said template, type name T, type name T1, I guess, auto compose TA T1B, and then we have arrow, and then it says decl type A plus. Interesting, interesting. There are two syntaxes for function declaration. So we put a return type identifier. So this is what I'm more accustomed to seeing. And then we put auto identifier, argument declarations, arrow return type, which is what I saw here. All right, so let's take a look at some discussion. So they are equivalent. Now, when they are equivalent, why do you ever want to use the latter? Well, C++11 introduced this cool decl type thing that lets you describe type of an expression. So you might want to derive the return type from the argument types. So you try template, type name T1, type name T2, decl type, A plus B, compose T1A, T2B, and the compiler will tell you that it does not know what A and B are in the decl type argument. That is because they are only declared by the argument list. You could easily work around the problem by using decl val and the template parameters that are already declared, like template type name T1, type name T2, decal type standard decal val T1 plus standard decal val T2, okay, compose T1a, T2b. Let's see. Yeah, okay. Except it's getting really verbal. Excuse me. Except it's getting really verbose now. So the alternate declaration syntax was proposed and implemented, and now you can write template type name T1, type name T2, auto compose T1a T2b, arrow decal type a plus b, and it's less verbose and the scoping rules didn't need to change. C++14 also permits just auto identifier argument declarations as long as the function is fully defined before use and all return statements deduced to the same type. The arrow syntax remains useful for public functions declared in the header if you want to hide the body in the source file. Okay. Somewhat obviously, that can't be done with templates, but there are some concrete types, usually derived via template metaprogramming, that are hard to write otherwise. Okay. So, yeah, so there we go. Now, do we understand if there's a reason that we would have done this here? I feel like we could have perhaps just left this off. So let me go to my code. Here, let me clang format first. And then what if I just change these to auto? So now that says it's okay, I guess. And test says it's okay. All right, let's resubmit that. All right. So I just wanted to check that. So auto here is fine, at least in the version that I'm using. And apparently on exercism fine as well. Let's go to the next one. We mark this done. That was number 5, right? Okay. Let's go to the next. It's going to be vehicle purchase. Let's take a look. Okay, so let's look at our README. All right, so we are gonna say in C++ you can compare values using the comparison operators. Equal, not equal, less, less or equal, greater, greater or equal. The result of these comparisons is always a Boolean value, right? So if we do like a not equal 4, then we get a true because we decided it was 3 already. A greater than 5, we get a false because 3 was not greater than 5. The operators double equal and not equal check whether a value is equal to another or not, respectively. 2 double equal 3, false. 2.1 not equal 2.2, true. Float comparison. True. String comparison. Okay, hello, double equal hello. The other operators check if one value is greater than, greater or equal to, less than, and less or equal to another value. Okay, so hello, less than world, true, string comparison. So this kind of comparison is available for numbers and strings. When comparing strings, the dictionary order, also known as lexicographic order, is followed. Sweet. Conditionals in C++ are similar to conditionals in other languages. The underlying type of any conditional operation is the bool type, which can have the value of true or false. Conditionals are often used as flow control mechanisms to check for various conditions. An if statement can be used, which executes its code if the underlying condition is true, like this. Value val, value equals val, return was val. Fun. In scenarios involving more than one case, many if statements can be chained together using the else if and else statements. Ooh, fun. So if number greater than 0, return positive, else if number less than 0, return negative, else return 0. Okay, fair enough. Since C++17, if statements can also include a short initialization statement that can be used to initialize one or more variables for the if statement. So in this example, we said if int v 2 times num, v greater than 10, return v. Okay, kind of fun, right? Any variables created in the initialization cannot be accessed after the end of the if statement. Great. That's great. So in this exercise, you're going to write some code to help you prepare to buy a vehicle. You have 3 tasks, one to determine if you need a license, one to help you choose between 2 vehicles, and one to estimate the acceptable price for a used vehicle. Okay, so some vehicle kinds require a driver's license. Assume only the kinds car and truck require a license. Everything else can be operated without a license. Nice. Choose between 2 potential... Oh gosh, I've seen this one before. This one is so weird, but... okay. You evaluate your... I don't know which one. I probably saw this in JavaScript, I don't know. But this is a funny one. You managed to narrow it down to 2 options, but you need help making the final decision. For that, implement the function choose_vehicle, option 1, option 2, that takes 2 vehicles as arguments, and returns a decision that includes the option that comes first in lexicographical order. So we chose the Toyota Corolla because the T came before the W. All right, and then for the Beetle and the Golf, it was all the same, but then the B was before the G in the alphabet, so we chose the Beetle. Okay. The returned string should follow the pattern of chosen vehicle is clearly the better choice. Okay, that's fine. Cool. Calculate an estimation for the price of a used vehicle. Now that you made a decision, you want to make sure you get a fair price at the dealership. Since you are interested in buying a used vehicle, the price depends on how old the vehicle is. For a rough estimate, assume if the vehicle is less than 3 years old, it costs 80% of the original price it had when it was brand new. If it is at least 10 years old, it costs 50%. If the vehicle is at least 3 years old, but less than 10 years, it costs 70% of the original price. Okay. Implement the calculate resale price, original price age. Yeah, I don't love this one. It's so weird, but fine. There are other ways if you want to practice. Yeah, let's just jump in here. Let's see. What is this what band do I think this is? Is this shoot. I've forgotten the name. I think it's I'm not gonna look just yet. I think that it'll come to me. I should know this band name, but it's not coming to me. Okay, so okay, I was wondering if I could use the curly brace syntax in this way, but I'm thinking no. I'm coming to the end of the track. Okay, let's see what it is. Even seeing this album cover art, it's not coming to me. LC. Yeah, I've completely forgotten the band name. That's why it was bugging me. Well, I'm about to look it up, and I don't think I'll forget it again. Mr. Sunshine track. I think Mr. Sunshine is a common song name. Okay, let's look at it here. Lydian Collective. Yep, I had straight up forgotten the name. Lydian Collective. I'll try to remember that from now on. Okay, so here we go. All right, I'm cool with that, I think. So then we are gonna say if age less than 3.0, return original price times 0.8, right? If age less than 10.0, return original price times 0.7, okay? Return times 0.5. Yeah. All right, how's that? Lydian Collective. I'll try. I'll remember that next time. Okay, so let's go exorcism test. And let's go. Okay, let's submit. Okay, is that number 6? I think so. Okay, so that one's passed. Let's take a look at a community solution. Nacho Goro, let's take a look. Okay, so... Oh, they did standard min. That seems like a good idea. That was from algorithm. Okay, so, and then here we used a ternary, so that's cool too. Const double factor equals... interesting, interesting, interesting. Yeah, let me try this with a... interesting. Let me try something a little similar in mind, just to see what it does. So here, let's say const double multiplier, all right? And then I'm gonna try it with the curly braces. Let's see what happens. So I'm gonna say age less than 3.0 and 0.8. So I'm not using the typical ternary. The typical ternary is better, but I'm just curious about this. So I'm gonna say and 0.8 or age less than 10.0 and 0.7 or 0.5. And then I'm going to say return. Okay, so now it says non-constant expression cannot be narrowed from type bool to double in initializer list. Yeah, that would make sense. So I think it does have to be a ternary if we want to do it like this, and that's fine, that's good. Implicit conversion from double to bool changes value from 0.8 to true. Yeah, that makes sense. So we can't, in like JavaScript, we can do something like this. In Python, I'm not sure. But in JavaScript, we can totally use ands and ors as an alternative to a ternary. And when you use JSX, you see that kind of stuff fairly frequently because in JSX, when you put something into those template curly braces, you can't use a statement. You have to use an expression. So you can't use an if statement. But anyway, let's do this like this. Is that allowed? That's interesting. Okay, so let's see. Oh, I meant to test. Okay, so the test is fine. So let me Clang format again. Okay, so now let's look. So this is what we've got. I actually rather like that. So we've done const double multiplier, And in the curly braces, we've put this expression. And to be fair, this is ternary expressions all mixed up, so I don't love that. But I think I do rather love that we can put that expression in there like that. All right, I'm gonna move on. So that was that number 6? Let's see. So I put in another iteration, and I believe I want to say that was number 6. Yeah. Okay, let's keep going. I actually do think that this is helping me, even if it's sort of just slow going and just because it's all pretty simple stuff. Let's do this one now. Making the grade. I think this is helping me, honestly. And you know why I feel better now? I feel better now because I drink this stupid Rockstar. All right, let's see what this one's about. Okay, this is good stuff. This is stuff that I need help with a little bit, or maybe a lot. We'll see. So, C++ offers different containers to store elements of the same type in an ordered way. There is array for containers of a fixed size and vector, which comes with dynamic resizing capabilities. Love it. That's pretty amazing. Okay, so when you declare an array or a vector, you need to specify the type of elements that, excuse me. Oh, what is the comma doing here? That's out of place. You need to specify the type of elements that container will hold. Arrays also need a size. Look at these examples to see the two container types initializations. Okay, so here's an array where we put the type in here and the size. So we put string 3, and then we put the name, all right, and then we put the elements. All right, so far so good. Vectors usually need more space as they allocate memory for further growth. You do not need to specify a size. Okay, so we chose a vector of int. We gave it the name, countdown, and then we put the elements. Great. Note, you do not need to know the exact mechanics behind the template concept yet. It will have its own concept further down the syllabus tree. Okay, works for me, baby. All right, so now we're going to look at element access. Vectors and arrays share the same functions to access their elements. You can use the member functions front and back to get the first and last elements of the container. Here's something. I think this font is nice, but I've kind of wanted to go to Comic Sans. On my Mac, I've switched my terminals mostly to Comic Sans, and I actually rather like it. Sorry, it's total tangent. I get like this when I'm tired, I guess. But let me just let me just search. What do we have for comic? What options are here? Comic Book Archive Viewer, cool. Microsoft TrueType Core Fonts. Zathura. Vigor. NV with the evil paperclip. I don't know what that is. Oh, wait. NV? That's a text editor, isn't it? NV. What is the evil paperclip? Okay. NV with the evil paperclip. Microsoft Word Office Assistant Paperclip. What the heck? Okay, this site is dead. Okay. Anyway, where's, let's see, do we have a comic new, Humor Sans, Stay Puffed, Gnome Books, Text Live Fonts, Fonts Anonymous Pro. Let me just look at it on Nerd Fonts. Nerd Fonts, right here, and comic. Yeah, this one. So I was using this one, and I think I like this. So we can download it like this, but I've usually... Oh, you know what? I should just brew install it. Oh, wait. It's Cask. Cask works on Mac only, I believe. Because a Cask is a Mac OS native package, right? So if I do this, it's gonna tell me no, right? Or yeah, Mac OS is required for this software. I like to get it through some manner of a package manager, if I can. Should I try getting it through R? I haven't tried this before. This is gonna be a rabbit hole that I should do when I'm offline, actually. But I should do this. So I'm gonna star this, but I'm gonna go back to what I was doing. Okay. Back to what I was doing. So vectors and arrays share the same functions to access their elements. You can use the member functions front and back to get the first and last elements of the container. There is also at and the square brackets operator to access specific elements. So countdown sub 0, 3, so there it was. Countdown at 2, 1, there it was. Countdown sub 1 equals 4, okay, so now we modified it, sure. Indie rock back equals Yaz. Okay, so we just changed the last one. Okay, cool. If you pick a position that is not in the range of your container, the square brackets might lead to undefined behavior. Uh-oh. The at function would raise an exception, which might make your life easier in the long term. Let's keep that in mind. That sounds like a good tip. Okay, so as a vector is not fixed in size, it is possible to add or remove elements. Two common functions for that purpose are in-place back and pop back. Okay, so in this example, we say we have witches called Holly, Alyssa, and Shannon, and then we popped the back, and then it's like, oh no, Shannon is no longer with the witches, and then we said in-place back Rose. Rose has joined the team. Okay, so cool. That seems good. You can check the containers for emptiness with the member function empty. If you want to know the number of elements, you can use size. Cool. All right, so now you're a teaching assistant correcting student exams. Keeping track of results manually is getting both tedious and mistake-prone. You decide to make things a little more interesting by putting together some functions to count and calculate results for the class. Okay, so 1, rounding scores. While you can give quote-unquote partial credit on exam questions, overall exam scores have to be ints. So before you can do anything else with the class scores, you need to go through the grades and turn any double scores into ints. So create the function roundDownScores, all right, that takes a vector of student scores. The school's requested rounding is a truncation. Lucky for you, C++ can cast one type into another with static cast. The static cast conversion from double to int cuts off any digit after the decimal. This function would take the input vector, should take the input vector and return a new vector with all the scores converted to ints. All right, so in the example, we get student scores that have a bunch of scores, but when we get them back, they all become ints. All right, that's fine. So there are other methods which achieve the same result, but a cast is a common site. So they'd said int new pi, and we said static cast int 3.14 plus static cast int and the rest of it. Okay, and it ended up as 3, sure. So part 2, non-passing students. As you were grading the exam, you noticed some students weren't performing as well as you'd hoped, but you were distracted and forgot to know exactly how many students. Create the function countFailedStudents that takes a vector of student scores. This function should count up the number of students who don't have passing scores and return that count as an integer. A student needs a score greater than 40 to achieve a passing grade on the exam. Okay. So we count failed students, and it says 5, so were there 5 that were under 40? There was 1, 2, 3. Oh, it has to be greater than 40. 40 is not good enough. So 1, 2, 3, 4. The best. The teacher you're assisting wants to find the group of students who've performed the best on the exam. What qualifies as the best fluctuates, so you need to find the student scores that are greater than or equal to the current threshold. Create the function above threshold, taking student scores, a vector of grades, and threshold, and int, the top score threshold, as parameters. This function should return a vector of all scores that are greater than or equal to threshold. All right, cool. So then calculating letter grades, the teacher you're assisting likes to assign letter grades as well as numeric scores. Since students rarely score 100 on an exam, the letter grade lower thresholds are calculated based on the highest score achieved and increment evenly between the high score and the failing threshold of less than equal to 40. Oh, interesting. That one's actually kind of interesting. So create the function letter grades that takes the highest score on the... They're going into a lot of detail on it, though. Okay, that's fine. All right, so American style grade interval. So where the highest score is 100 and failing is less than equal 40. So F is less than equal 40. D is 41 to 55, C, B, A. But then in this case, the highest score was 88, I guess. So then A became 77 to 80. The score needed to avoid failing is always 41. The remaining score range from 41 to the highest score should be divided into 4 equal intervals, 1 for each letter grade. Subtract 40 from the highest score to get the total range of scores that qualify for letter grades, A to D. Divide this total range by 4 to get the size of each grade interval. Add this interval size to 40 repeatedly to calculate the lower bounds for each letter grade. Okay, so then matching names to scores. You have exam scores in descending order and the respective student names sorted in the order of their exam scores. You would like to match each student's name with their exam score and print out an overall class ranking. All right, so student ranking, and then in this case we have scores and we have names, and then we're supposed to say, oh, each one becomes a string, I guess. So number 1 is Josie at 100. Number 2 is Sarah at 99. And so on. You can assume each argument vector is sorted from highest score to lowest score. Well, that sure simplifies things, right? I guess that's fine. Okay, so although a perfect score of 100 is rare on an exam, it is interesting to know if at least one student has achieved it. Create the function perfect score with parameters student scores and student names. The lists are the same as in task 5. The function should return the first name as a string of the student who scored 100 on the exam. If no 100 scores are found, an empty string should be returned. Okay, so here we have a 100, so we return the name, Fatima. And here we don't have one, So we returned empty string. Okay, so let's go ahead and do our thing. Making the grade. The grade, if I could spell it. Okay, so to do, implement round down scores. All right. Cool. So let's see. Did we talk about the README? It didn't really talk about iterating over the vector, really, did it? It didn't talk about doing a loop. So now I'm wondering what it did talk about. I think yeah, it showed doing something, right? Okay, so we want to return. So we're going to say standard. I don't even like to say that. Let's just say and then we're going to say, actually, ha, 15 substitutions. Okay. So we want to say we're going to have a vector int, and it's going to be rounded down. And what do we put in here? Nothing? Or do we put in... What if we put in student scores? Is that crazy? There's no way. It can't allow that. Let me go back. What did it say in the README? Because it didn't talk about loops. So I'm wondering to myself whether it gave us a hint for what we're going to do if we don't have a loop to use. Okay, I'm just going to do it and then look at... I'm going to be curious to look at other people's solutions to this one. So we won't do that. We'll just go for int student scores size. I guess let's go in place back like they said, right? And then we'll go int student scores at I. Should we give that a shot? Let's give that a shot. All right, so then this one. Count the number of failing students out of the group provided. So I'm going to use this for loop at first. I want to practice just a couple different ones, I think. I don't know if there's really a point to that, but I kind of do want to. So let's add a failing grade. Right, like that. Okay, implement above threshold. Oh, should this... I honestly, before today, I didn't know that that was even a syntax in C++, and now I do want to try and use it all the time. Okay, so, cool. Yeah, all right, so now let's go for... Oh, actually, well, yeah, this is fine. So 0, I less than student scores size, I plus plus, if student scores at, and we'll go I, and it's based on the provided threshold. Was it greater than equal? I left out a brace there. Oh, and actually, this isn't even needed. That can be left out so that it's a default value. I don't know if that's better. I think maybe having the z is better, or excuse me, having the 0 is better. All right, so returned type int to function return type vector int. Oh, this says how many, but we're actually supposed to return them, so that was silly of me. I guess I was a little thrown off there because it says how many, but we're not actually counting, we're actually returning them. Okay, so then this one is array int for letter grades. Okay, so it had this long explanation of what we were supposed to do here, right? So, grade thresholds. So we're gonna say array int for grades, and we know failing grade is going to be in there first, but then we have to calculate the others, right? So I guess we can probably just calculate them right here if we want to, right? Let's do that. Okay, so it'll be failing grade, and then the second one is highest score minus failing grade. Well, I guess it's failing grade plus, and then it's going to be this subtracted, and then it's going to be divided by 4, no, 3. So I guess it is 4, right? And this will be 1 times, right? And then this will just be 2, and this will be 3, I believe. And so if that's all it is, then let's just return that. Yeah, let's just leave it like that. I'm not sure if that's really the calculation, but I think maybe. If not, I'll come back and fix it. Let's do this one. Student ranking. Students' rank, name, and grade information in ascending order. So here, we're supposed to make a string of each one, right? So let's say vector string rankings. And then we'll say, again, for int I, okay, so now we are going to say rankings in place back, and now we're going to put a number. So it's going to be I plus 1, like this, I guess, and then add to dot, and then add the name, so student names at I, and then plus the ranking, right? Or the score, actually, probably. Okay, so now here, I think, do we have to do like I to A? Is that what it is? Use of undeclared. Okay, let me take a look. C++ I to A. I to A CPP reference. This one? Oh, iota. No. I to A. Is this it? Oh, wait. A to I is here. Interprets an integer value in a byte string pointed to by string. The implied radix is always 10. And this is string. Okay, so what about going the other direction? S to I. No. From, wait a minute. Convert a... See also, convert a string to a signed integer. Convert a string to an unsigned integer. Convert a byte string. Oh, shoot. Iota to string, that would make more sense. Ha! Okay, yeah, let's try that. That would make more sense. Okay, so not I to A. To string. Ah, yes, how about that? Ah, that would make more sense. Okay, so did I miss something? Expected... that... Oh no, this one also has to be two-string. That would make more sense. Okay, so then let's return... Okay, so then this one, create a string that contains the name of the first student to make a perfect score on the exam. Okay. So we already have the empty there. So I guess we'll just go for int I less than student scores size, I plus plus, if student scores at I is 100, return student names. So pretty simple. I think this one's probably the most interesting, and I might have gotten the arithmetic wrong here. Let's see. So it seems like it's probably about right. Let me go ahead and review it in the README. So to calculate it, it said the score needed to avoid failing is always 41. The remaining score range from 41 to the highest score should be divided into 4 equal intervals, 1 for each letter grade. So subtract 40 from the highest score to get the total range of scores that qualify for letter grades. I think we did that, right? Yeah, so we subtracted the failing grade, which was 40. But this one should actually be 41. So, oh gosh, what did I just do? So let's change that to 41, but then the other thing it says is divide by 4. Honestly, I think I skimmed over this. I might have read it out loud. And then add this interval size to 40 repeatedly to calculate the lower bounds. I think we're good. If I just change this one to 41. And then I think we need to add 1 on each of these others as well. I kind of want to just test it first. It's been kind of slow to build. Okay, so now let's go ahead and... No, making the grade test. Yeah, this one. So we did get 5 failed. And let's see. 41. Oh, expected. 56, 71, 86. So it was add... I think I said that out loud, didn't I? That it was probably having to add 1. And then I was like, I want to test it first. Whoops. There it is. Alright, so I was thinking that it has to be add 1 on each of these. I guess it's fine. Oh, still 2 failed? Okay, so I... Oh, yeah. I forgot about the string formatting. So I've got 1 dot, but I left out a colon, and I forgot that I needed to check that. Okay, so let's put the colon in there, which I believe goes here. Okay, so is that better? I think so, yeah. Cool, let's submit. There it is. Okay. Okay, so let's for sure look at some community solutions for this one. Highest rep user, let's look at one from S. Bromberger. Let's check it out. Okay, so let's try using this style of loop where we do, it's kind of like a for each type of thing. So here we did vector and we reserved that amount, and that seems good, right? Let's look it up. C++ vector reserve. Yeah, let's take a look here. Increase the capacity of the vector to a value that's greater or equal to new cap. If new cap is greater than the current capacity, new storage is allocated. Otherwise, the function does nothing. Sounds like a winner to me. Okay, so yeah, let's totally make those changes right now. Okay, so instead of using I, let's totally go for and go double score in student scores. That seems way better. And so let's not do that. And then this becomes score, right? Yeah, seems good to me. And then let's add rounded down reserve student scores size. Okay, cool. All right, so now let's do that here as well. So it is for int score in student scores. Yeah, way better, way better. And then this becomes score, love it. And then let's put the reserve in there. Oh no, we don't need the reserve, never mind, what am I saying? All right. Yeah, that is so much better, so much better. Okay, so for, and this is going to be int score in student scores, right? And here let's reserve again, scores above threshold, reserve, student scores size, cool. All right. I'll leave this one alone. All right, so then here's another loop. So we're gonna go, oh, but this one is different because now we have two vectors. So if we just use this type of loop, this by itself is not gonna work. So I'm gonna leave these ones alone and I'm gonna resubmit, and then I'm gonna look at what else that other user did. Okay, so resubmit. Cool. Okay, so let's see what else. So we did reserve. They used in place back. Okay, so they used static cast. Now that's interesting as well. So I just put int in parentheses. So what is the difference between static cast? I bet there's a good Stack Overflow answer for this. C++ static cast versus plain parentheses. Cast. Stack Overflow. Give me Stack Overflow. Let's see. Okay, so is this C++? Yes. Okay, so they have one with parentheses, and then they did one that was static cast, and then one that was dynamic cast. Okay, so let's see what the answer says. Static cast is used for cases where you basically want to reverse an implicit conversion with a few restrictions and additions. Okay, that makes sense, I think. So regular cast, so C-style cast. A C-style cast is basically identical to trying out a range of sequences of C++ casts and taking the first C++ cast that works without ever considering dynamic cast. Needless to say, this is much more powerful as it combines all of const cast, static cast, and reinterpret cast, but it's also unsafe because it does not use dynamic cast. In addition, C-style casts not only allow you to do this, but they also allow you to safely cast to a private base class, while the equivalent static cast sequence would give you a compile time error for that. Some people prefer C-style casts because of their brevity. I use them for numeric casts only and use the appropriate C++ casts when user-defined types are involved, as they provide stricter checking. Okay, so now let's go back and read what actually was said here. So static cast performs no runtime checks. This should be used if you know that you refer to an object of a specific type and thus a check would be unnecessary. Okay. So that makes sense to me. So in this example, you know that you passed a myClass object, and thus there isn't any need for a runtime check to ensure this. Okay, so myClass was passed in here, and here we know that it was myClass. Okay, I mean, fair enough. Dynamic cast is useful when you don't know what the dynamic type of the object is. It returns a null pointer if the object referred to doesn't contain the type casted to as a base class. When you cast to a reference, a bad cast exception is thrown in that case. Okay, you cannot use dynamic cast for downcast, casting to a derived class, if the argument type is not polymorphic. For example, the following code is not valid because base doesn't contain any virtual function. Okay, so struct base, struct derived, right, so extends base, I guess. Derived D, base star B equals address of D. Dynamic cast, okay, so this was invalid. Not polymorphic. This part, this part is beyond me, actually. Boost 2 additional casts? Oh my goodness gracious. All right, well, I'm going to leave that alone. Okay, let's see what else this user did. So they had a count. We went through the scores. Okay, so that seems fine. Yeah, I think that's okay. So they did thresholds 41,000. I think I like my way, but let me take another look. Failing grade +1, +1 plus all that. I think I like my way. So this, he did highest score -40 divide 4.0. So they made it a double. and then they static casted to int. I equals 1, I less than 4, plus plus I. Okay. Yeah, I mean, it seems good. I think I like my way too. I think they're both good. But maybe there's, I don't know if there's something, some people might not like my way, and I would understand that. Okay, now let's look at this one. So they did use I equals 0, I less than student score size, plus plus I in both cases. This one's pretty much the same as mine. And now what about this one? Okay, so they did do a reserve here. Yeah, that's pretty much the same as mine. Okay, I'm cool with that. I'm going to mark this one on my paper. I think that was number 7. And I'm going to do one more and call it a night. Last one. Let's close these. Oh, that one's not marked as complete yet. Okay, number 8. Let's do it. Last one for tonight. It's going to take me a while to learn much. I'm still at like the very, very beginning stages here, but it's all right. Interest is interesting. Let's take a look. So, here we go. We're going to learn something. Oh, it's about loops. Cool. Loops are used to repeatedly execute some logic. The two most common types are the while loop and the for loop. Cool. There's also the for each loop that will come up in a later concept. The for loop consists of a header and a code block that contains the body of the loop wrapped in curly brackets. The header consists of 3 components separated by semicolons. Init statement, condition, and another expression. Each of these may be empty. All right, so it's a 3-clause for loop. Love it. And then there's something inside there. The init statement component is code that runs only once before the loop starts. The condition component must be some expression that evaluates to a Boolean and controls when the loop should stop. The code inside the loop will run as long as this condition evaluates to true. As soon as this expression evaluates to false, no more iterations of the loop will run. The expression component is some code that will run at the end of each iteration. The while loop executes its body as long as its condition check is true. The code snippet below shows how to transform a for into a while loop. Okay, so we are showing like the same thing, right? So the init statement came first, that's fine. And then we had a condition, which is the only thing that goes in here for the while. And then this part went here. And then after this part, some statement, we had to put this. So easy peasy. So interlude, increments and decrements. When working with loops, it is often required to add one or subtract one from a counter variable, which keeps track of the iterations. This is so common that the incrementing/decrementing actions have special operators, double plus and double minus. They come in a prefix and a postfix form. The prefix changes the variable before use in the statement and the postfix version afterward. You probably want the prefix version most of the time. Okay, so int a, 3, int b minus minus a, so b is 2, a is now 2, int c, a plus plus, c is 2, a is now 3. Love it. Okay, for loop example. The init component usually sets up a counter variable. The condition checks whether the loop should be continued or stopped, and the post component usually increments the counter at the end of each repetition. So this is our classic 3-clause for loop. Amazing. So we just go through and we add some numbers from 1 through 10 to our sum, or 1 through 9, I guess. So this loop will sum the numbers from 1 to 9, including 9. Okay, so break and continue. Inside a loop body, you can use the break keyword to stop the execution of the loop entirely. So int sum2 while true, sum times equals 2. If sum greater than 1,000, break. Sum is now 1024. Okay, cool. Yeah, that's fine. So in contrast, the keyword continue only stops the execution of the current iteration and continues with the next one. Int equals sum. So we did for int I1, I less than 7, plus I. If I mod 2 double equal 1, continue equals sum plus equals I. So kind of a simple illustration of continue. That's fine. So if we go through this, we say, okay, so it's 1 to begin with. Then we're going to say, okay, so I mod 2, so 1 mod 2 is 1, so we're just going to go right back up to the top, and now we increment, and now it's 2, and now we get to here, but now 2 mod 2 is 0, so we don't continue, and we add 2 here, right? And so yeah, so then we'll add 4 as well, and then we'll add 6 as well, and we end up with 12. It is usually easier to understand the logic of the loop when the use of break and continue is minimized or entirely avoided. Both keywords skip certain sections of the code and make it often more difficult to follow along. All right. In this exercise, you'll be working with savings accounts. Each year, the balance of your savings account is updated based on its interest rate. The interest rate your bank gives you depends on the amount of money in your account. Its balance. 3.213% for a balance less than $0. Balance gets more negative. Aw, man. Aw, man. Okay, 0.5% for a balance greater than or equal to $0 and less than $1,000. 1.621% for a balance greater than or equal to $1,000 and less than $5,000. 2.475% for a balance greater than or equal to $5,000. You have 4 tasks, each of which will deal with the balance and its interest rate. 1. Calculate the interest rate. So, implement the interest rate function to calculate the interest rate based on the specified balance. Okay. Interest rate 200.75, and we say, oh, it's going to be 0.5. Okay, so it's a percentage. Calculate the interest. Implement the yearly interest function to calculate the interest based on the specified balance. All right, so if we put 200.75, then I guess we're going to multiply that by 0.005, right, and get just over $1. Fine. Okay, calculate the annual balance update. Implement the annual balance update function to calculate the annual balance update, taking into account the interest rate. Okay, so basically we just added the number that was passed in to the yearly interest, right? Calculate the years before reaching the desired balance. Oh, interesting. The minimum number of years required to reach the desired balance, taking into account that each year interest is added. Oh, okay, so this one, wait a minute. So the exercise is about loops, but this doesn't have anything to do with a loop. This doesn't have anything to do with the loop. This doesn't have anything to do with a loop. This is the only one that potentially has to do with a loop, but usually I would tend to calculate this using a formula. So we can try it both ways, I guess. It's getting pretty late, though. Let's see. This is the kind of thing I think I would usually calculate this using a formula, not a loop. But let's go ahead and jump in here. I think let's do it with a loop first, and then let's try it with a formula. Because off the top of my head, like, I don't have a formula memorized, but I think it's pretty easy to figure it out. So here we go. So to do, implement the interest rate function. Okay, so we know that there were like several options, right? So we're gonna say if, can we do a switch? Let me just try a switch. So if, I'm not sure if I remember how this works. Case, no, we can't do that. I don't think you can ever switch on a double. You can switch on like an int, but don't think you're ever allowed to switch on a double. Let me just look it up. In C++, can you ever switch on a double? I think it's not allowed, but let's see. This is Objective-C. I don't think you can. I don't think you ever can. Can't switch on a double. Okay, good. All right, so let's say if balance less than 0, return 3 point whatever it was. Okay, let me look again. It was 3.213. Okay. Oh, not V, not V. Is my arrow key not working? Okay. What is happening? I wonder if my keyboard battery is low. I think it's fine. Okay, now I don't remember what it was. Was it... Okay, I'm just gonna look again. 213? 3.213? 213, okay. Balance less than 500. Return 0.5. Wait, was it 500 or was it 1,000? I think this was 1,000, right? And this one I think was 5,000, and it was returned 1 point. I don't remember. It was, yeah, 1,000. 1.621. Okay. There. And then in the final analysis, return 2 point, whatever it was, 2.475. Oh, you know what? I said I would usually do this with a formula, but no, I would not do this with a formula. Because the formula, if the interest rate is constant, then the formula is simple. But since this interest rate is changing, then I think I don't know of a simple formula for it. There might still be a formula, but if it's simple, I doubt that it's simple. And if it is, I just don't know what it is. So a loop makes way more sense. It's way easier to do with a loop, I think, than a formula. Yeah, I'd forgotten that. So, in short, I would use a formula if it were constant interest. But in this case, because the interest changes, I would not use a formula. All right, so let's finish up. The yearly interest. Okay, so we're just gonna take balance times 0.01 times interest rate. Okay, so then for this one, we're going to return balance plus yearly interest. Okay, and then finally here, we will go while balance less than target balance. Balance equals, oh, and we need a count. So int count equals 0. And then here we're going to say balance equals annual balance update. And then we're going to increment the count. Still, it's been slow to build. I don't know. It might have always been this slow to build. Okay, let's try our tests. It says all tests passed. So let's see if we get a fail. Yeah, we got quite a few fails. Darn. Okay. Are they all years until desired balance fails? Oh, man. 1.5. Oh. Well, that would mess me up. I straight up mistyped that. I have 1.521. Is it supposed to be 621? I think it is. And I'm pretty sure I knew that. Yeah, 1.621. Okay, well, let's try again. Ah. This is why it's so good to have tests. Okay, so now they're all good. Okay. So, I'm just about done here. I'm going to review somebody's community solution. So, let's see. Highest rep user. Let's look at Nozomirin. Here we go. Okay, so they said, yep, that's pretty much what I did, I think. Less than 0, less than 1,000. Yep, okay. Yep, pretty much what I did. I think that's fine. They added that. That's cool. Yep, I mean, it's pretty simple, so I think that's good. I'm going to mark that as complete, and that was 8 for today, which I'm fine with. I think that's a decent amount. Actually, you know what? That was really slow. I should have done more than that today, but I'm not going to beat myself up over it. I'll just come back another day for more, but 8 is not that many. I was going to try to give myself a pat on the back, but no,